there. Basically, this Intercontinental Advanced Materials for Photonics Summer School / Australian Winter School will enable you to work at the forefront of material science and photonics, and you'll be able to have a lot of time to discuss emerging uses of light for control of fundamental study of matter and advances in the use of materials to control light. Now, this summer school has been at many places around the world, so we are very pleased to be able to do it in Australia. And we hope that you will enjoy yourself here in Australia, both in Sydney and Brisbane. I hope that the rain will stop, so you will be able to do some sightseeing. What we aim to give you here is a series of lectures, and Ivan will tell you more about it, series of lectures which otherwise would be very difficult to combine in one place and have so many people talking about this stuff to you. So it's 3 weeks. I don't know how many of you are participating in all 3 weeks, but those who are, you are doing nonlinear optical materials, photonics, crystals, and metamaterials here in Sydney under the auspices of the very well-established and great centre, which I'll tell you a few words about, QDOS. And then you'll have a workshop on complex interactions and mechanisms in organic photovoltaics, which will be in Brisbane, where there is a great centre, COPE, which is dealing with organic materials for photonics and electronics. And you'll be having possibility of visiting the labs and talking to a lot of people from there. And there are people from all around the world coming to give you lectures in this area. And then in the third week, we'll be talking about nanoscale and microscale optical control of matter. So light-matter interaction and all aspects of that. So, right, so, no, I went the wrong way. Okay, no, it doesn't want to go anywhere. Okay, enter. Okay, so what I would do is to spend a few minutes on telling you how great we are as far as optics and material science in Australia is concerned. We are a small country, a lot of you coming from rather biggish countries, but for a small country of 20 million people, we have a lot of optics going on. And in actual fact, I'll be a little bit cheeky here, because I'm from optics and not from material science, so I'll tell you more about optics than material science, and my colleagues in Brisbane will tell you more about material science. So, what's going on here? My thing doesn't work. Okay, so we have Australian Optical Society, which is a non-profit organization for advancement of optics in Australia. And we have a lot of young members of this organization, and we try to provide forum for people who are interested in optics. And we are after strengthening optics teaching in Australia. And of course, we are promoting research in optics in Australia and internationally. And we are after collaborations within and outside the country as far as optics is concerned. So, optics has been a strength of Australian science for some time. It has been national priority for the government, and we were able to get a little bit of funding from the government to promote optics in Australia. And we have had great scientists who made optics very strong in Australia in late 50s, early 60s. But we are in the new era of optics at the moment in Australia. And what I listed here are the major ARC, Australian Research Council Centres of Excellence, which deal with optics. So Australian Research Council Centres of Excellence are, if there are too many people here from QDOS, I'm preaching to convert it, but for those people who are from outside, what it means is that Australian Research Council decided, and with that Australia decided, that we wanted to build strong centres of excellence in the our strength of research. And you can see that there are so many of them in optics that it are related closely to optics that it does show you the incredible strength of optics in Australia. So we have Centre of Quantum Atom Optics, and all of those centres involve many universities and many researchers from around the country, as well as many collaborations outside the country. So Centre for Quantum Atom Optics links diverse concepts from optics, photonics and ultra-cold atoms and coherent matter waves into new scientific directions. It has set foundation for the development of new instruments for the future that will operate at the fundamental limit of sensitivity. So in that center, we try to learn also how to use the uniqueness of quantum systems. So this is looking at quantum/optics, quantum science and optics, and use it for cold atoms or ultra-cold atoms, and then come up with new quantum devices. Then we have Center for Quantum Computer Technology, which is research into fundamental physics and technologies involved in building at atomic level solid-state quantum computer, and also an all-optical quantum computer. So these are two architectures that people for years now were trying to develop here in Australia to reach, to build qubits and to be able to progress this technology further. Then we have a Center for Ultra-High Bandwidth Devices and Optical Systems, and a lot of you here are from this center. This is a center led from Sydney Uni by Ben Eglinton, and I understand that on Friday he not only will talk to you, give you lectures about research in this area, but also tell you a lot about the center. So I will spare myself telling you too much about it. But it's a very successful center and involves many universities, like all the others are. Then we have a center in vision optics, and the center in vision optics has people from Australian National University, University of Queensland, University of Sydney, and University of Western Australia, and it aims at unraveling the cellular basis of visual sensing and processing, and revealing the algorithm that underlie the visual control of behavior and perception. And then we have Centre in X-ray Science, led from University of Melbourne, and there are again many universities involved in that. And this centre is involved in development of coherent X-ray diffraction for imaging biological structures. So there are many other centres of excellence around Australia in other areas, but these are the ones in optics. So as you can see, altogether there are probably 25 centres, and that many are in optics. So we pride ourselves to say that optics is our strength. And if this thing doesn't work, maybe that one will. No? I think my battery ran out or something. Yeah. Oh, here we go. Oh. No. All right. So, other organizations in Australia which are involved in optics is the Centre for Lasers and Applications in Macquarie Uni, which is here in Sydney, and I'm not sure whether you will have an opportunity to visit Macquarie Uni and see how much optics they do there. But their claim to fame is to do laser applications as basis in fundamental optics and electronics, physics, chemistry, and biology. So they're very well known in their developing new laser sources and then applying them for new areas in biology, physics, and medicine. Then we have the Australian Consortium for Interferometer Gravitational Astronomy, which is led by ANU, University of Adelaide, University of Western Australia, and Monash. And this consortium is dealing with research and development program aimed at improving the performance of laser interferometer gravitational wave detectors to reach the limits set by mechanics, quantum mechanics, lasers, and optics. So different parts of this consortium are dealing with different things. So for example, University of Adelaide is building super stable lasers to be able to use them for gravitational wave detectors. University of Western Australia are building oscillators which are incredibly precise, which will enable this sort of work to go on. ANU is trying them out and combining both of the laser sources and the systems, and Monash is also participating in the same sort of thing. Okay, now we are in very interesting stage at the moment because many of us are going to be interviewed for next round of centers. So we have done such a great job in the centers, so many of them applied for new round of 7-year funding. Shelley, was it 7 or 8-year funding? 7-year funding. And so all of a sudden we found ourselves in the position where in the 3rd week of our winter summer school, ICAM, 3 centers are going for interview. So Center for Quantum Atom Optics, which I told you about, is going for an interview. Center for Quantum Communication and Computing is going for rebid. The center based here with Benedictine as a boss, Center for the Ultra-High Bandwidth Devices and Optical Systems is going for rebid. And Center for Engineered Quantum Systems, which is a new one, which is dealing with nano-mechanical devices, both in optics and mechanics, is going for rebid. So we're hoping that next time you come for ICAM Summer School, we'll have all these centers being successful, and we'll be able to give you some lectures in new areas that we are applying for. There is also Institute of Photonics, so I will just give you a few examples of other areas, of other centers where Australia is doing good work. And there is Institute of Photonics and Optics, Optical Science at the University of Sydney, where you are. And this is basically an umbrella organization for the Kudos Centre and for many other areas that the University of Sydney prides itself in developing. So there is this first one is Kudos, then there is Fiber Optics and Photonics Laboratory, Astrophotonics, and I hope you'll be able to talk to the fellow behind that. It's very exciting developments in optics that take place in astrophotonics. Interdisciplinary Photonics Laboratory, Quantum Information, Optofluidics, Silica Fiber and Fiber Devices, Plasmonics, Microstructure Optical Fibers. I think that Ben will be talking about them. Fiber lasers, super continuum generation. So you can see that the amount of stuff that is going on, science going on in this institution is really great. Well, I should have taken yours. Another major activities in optics are sort of spread out all over the country, and one of the newer one is one led by Professor Tanya Munro at the University of Adelaide, and it's centered in expertise in photonics. So what she has built up is quite a tremendous lab in producing special fibers, and many of them are soft fibers, and so they can be used as sensors in biomedical and medical applications. Then there is quite a large group, quite new group in atom optics at Monash, and you will have one lecturer from Monash, Professor Chris Helmerson, who will be talking to you about light-matter interaction in the 3rd week. And what they do there is superfluidity in the presence of disorder and reduced dimensionality, quantum turbulence, but they also do things like building microscope for single molecules based on quantum principles. So that's very exciting young group being built up at Monash Physics Department. Okay, and the other major activities again, Center for Microscopy, Characterization and Analysis, driven by David Sampson, and what he is famous of is that he does optical tomography, and he with a lot of applications in medicine. And then there is also optics in Melbourne Uni, with big activity in optical imaging, both theoretical and experimental, group in cold atoms, And of course, the main hub for the Center of Excellence in X-ray Imaging is at Melbourne Uni. And then Macquarie Uni here is also doing research in photonics, in astrophotonics, microphotonic optical system, optical sensing and imaging, biophotonics, and so on. So this is supposed to give you a little overview of enormous activities for a little country in optics everywhere, so I will stop reading it all, but there is a lot of happening in these areas around the country, and you will have a feel for it after these 3 weeks. I hope that you will know a lot of people from around Australia from these areas, both here in Sydney and then those who are coming to Brisbane. And then my colleagues in material science will tell you more about material science around Australia. And now Ivana will be telling you more about the school.
Thank you so much. Let me try to connect.